Here's the story about how a solar eclipse moved a star. You're going to find out what that means if you watch this video. But here's how it starts. The early part of the 1900s, Einstein proposed his theory of general relativity, which basically says that matter changes space-time. There's like a space-time fabric in the universe. And matter isn't just in empty space, but matter actually interacts with the fabric of space-time. And it bends it. What that means is that light passing by a massive object like a black hole or a whole galaxy would actually bend. And so here's an example of what we mean by that. If somebody has a spear and they're going to try to get a fish that's in some water and they're going to throw the spear at the fish, they actually have to throw the spear not where they see the fish, but below, because the light coming out of the water bends. And so this is also how lenses work. Lenses, we put them over our eyes, and the lenses bend the light in a certain way to focus it at the right part for our eye. This is what Einstein's theory of general relativity said would happen to light when it was going by something really, really massive. Okay? At the beginning of the 1900s, we didn't know about black holes yet. In fact, that was a controversy that came up later based on Einstein's theory of general relativity. Could black holes exist or not? And but at the time, they just knew the most massive objects that we knew about were stars. The problem is it's hard to conduct an experiment to see if light is bending near a star, because the nearest star that we have to us is the sun. And we can see, the sun is changing its location relative to us and passing near stars. So the way to observe this would be that you'd have a star where the light is passing right next to where the sun is, and then the gravitational force from the sun would actually bend the light from that star. Well, you can't observe that because the sun is out during the day and it lights up the sky, and the sky blocks out all the other stars. So the only time that you'd be able to observe this is during a solar eclipse. Sir Arthur Eddington, an astronomer at the time, went to Chile to observe a solar eclipse to test Einstein's theory. And he made this announcement that he had observed the solar eclipse, and there was a star that they knew what the position of it ought to be, and that light coming right next to where the sun was, because the sun was blocked out during the solar eclipse, they could see the stars. And that star, the position had altered a little bit. It looked like it was in a different place. Not that the star had actually moved, but just the appearance of its location had moved because of gravitational lensing, the bending of space-time from the sun and the curving of the path of that light. Now this made a huge news sensation. This is a German scientist and a British astronomer, and they're working together on science. And this is after World War I. And so it kind of looks like there's going to be this new age of peace and harmony ushered in by science and scientific endeavor and cooperation. And we can see how that played out. So that's the story about how a star, or the apparent position of a star, looked different during a solar eclipse. Thanks for watching. And now, like and subscribe, and check out the information in the description below and the other content on my channel.